Hi everyone, Assalamualaikum. In this video, we are going to discuss partial derivative for implicit functions. From the function fxy, slope or gradient dy over dx equals to negative fx over fy. Fx means partial derivative with respect to x. And fy means partial derivative with respect to y. Equation of tangent line to the curve fxy is given by y equals to mx plus c, where m equals to dy over dx equals to negative fx over fy. M here means slope or gradient, right? Now, we look at example 1 from previous semester papers under partial derivative for implicit function. Find dy over dx for x cubed y plus 2e to the power of 2y equals to 1 over x at the point 1, 1 by using implicit differentiation. Write your answer in 4 decimal places. Step 1. Bring all the terms to one side and write the function given as f, right? So from here, we move all the function to the left hand side. So we get x cubed y plus 2e to the power of y, and then we move 1 over x to the left hand side. So we get minus 1 over x. And then we denote as f, alright? Step 2, find fx and its value at the given point. Okay, at the given point here means at point 1, 1. Means we need to find fx at point 1, 1, right? Fx here means partial derivative of f with respect to x. We treat x as a variable, and at the same time, we treat y as a constant, right? So, from f here, we can rewrite f equals to y x cubed plus 2e to the power of 2y minus x to the power of negative 1. Since we treat x as a variable, so to easily differentiate and to avoid error, we can write variable x at the back. Okay, we put variable x at the back and we write in different colors. Alright. Then we can find fx. Okay. Alright, to differentiate y x cubed, okay, y here means constant because we treat y as a constant when we find fx. Okay, so we just imagine, let's say we want to differentiate 2x cubed. We assume y here equals to constant 2. Okay, so when we differentiate 2x cubed with respect to x, we already know that the answer equals to 6x squared. But before that, actually, we just keep the constant 2 in front. Then, we differentiate x cubed using power rule. So, we get 3x squared. Then, after we simplify, we get 6x squared. So, same goes to constant y x cubed. Okay. So, we just keep y in front and then we differentiate x cubed. So, we get 3x squared. Alright. Then, 2e to the power of y here means constant because we treat y as a constant. And e here means Euler numbers, which is 2.718 something, which is constant. So, constant to the power of constant is also constant. And when we differentiate constant, it equals to 0. Okay. Alright, then we want to differentiate x to the power of negative 1. Okay, we can use power rule formula. When we have x to the power of n, right? When we differentiate, we move n to the front and then x and then n minus 1. So same goes to x to the power of negative 1 here. When we differentiate, so we move negative 1 to the front here, but we still have negative sign here. And then we have negative 1 here, or negative. And then x, and then negative 1 minus 1. So we get negative 2 here, right? Then we simplify. So we get fx equals to 3x squared y. And then minus minus equals to plus 1 over. We move x to the power of negative 2 to denominator using the properties of indices. So we get x to the power of positive 2 here. Okay. So our fx equals to 3x squared y plus 1 over x squared. Right? Right, after that, we can find the value of fx at the given point. So at the point 1, 1, okay, fx equals to, from here, we replace x equals to 1 and y equals to 1. Okay, so we get 3 times 1 squared times 1 plus 1 over 1 squared. Then we simplify, so we get fx equals to 4. Alright. So now we done find fx and its value at the given point 1, 1. Alright. Alright, then we can continue with step 3. Find fy and its value at the given point. Okay. We can find fy from f. Okay. F equals to x cubed y plus 2e to the power of 2y minus 1 over x. Okay. Alright. Fy means partial derivative of f with respect to y. We treat y as a variable, and at the same time we treat x as a constant. So to avoid error and easy to differentiate, we can write variable y in different colors. Okay. Then we can find fy. Okay, to differentiate x cubed y, x cubed here means constant because we treat x as a constant. Okay, so we can imagine, let's say we want to differentiate 8y over dy here. Okay, 8 here means, let's say we replace x here by 2. So 2 cubed equals to 8. So if we want to differentiate 8y with respect to y, we already know the answer equals to 8. But before we get 8, actually we just keep the constant 8 in front and then we differentiate y, which is equals to 1. So same goes to when we differentiate constant y. So when we differentiate constant y, we just keep the constant x cubed in front, then we differentiate y equals to 1. We can compare with this, right? And then, now we have constant 2 here in front. Okay, so if we have constant and then multiply by the function with variable, we just keep the constant in front. So we still have 2 here. And then to differentiate e to the power of 2y, okay, first we will get back e to the power of 2y. And then we multiply by derivative of exponent. When we differentiate exponent to y, so we get 2 here. Okay, so that's why we get this. Alright. And after that, 1 over x here equals to constant because we treat x as a constant. Means 1 over constant equals to constant. Okay. So when we differentiate constant, it equals to 0. Okay. 1 over x here, we no need to change into the form of x to the power of -1 because it's still constant. Okay, so we'll just leave as 1 over x here. Okay, and this is constant. When we differentiate constant, it equals to 0. That's why we get this. Alright. After that, we can simplify fy. So we get fy equals to x cubed plus 2 times 2 equals to 4 e to the power of 2y. Okay. Alright. Now we done find fy. Then we can find the value of fy at the given point 1, 1. So at the point 1, 1, fy equals to x cubed here. So we replace x by 1. So we have 1 cubed plus 4 e to the power of 2. Then we replace y by 1 here. Okay. Then we get fy equals to 1 plus 4e squared. Alright. Alright. Then we recall back. At the point 1, 1, we have fx equals to 4 in the previous slide. And we have fy equals to 1 plus 4e squared. Okay. Then we can continue with step 4. Use dy over dx equals to negative fx over fy. Okay. So now we can find dy over dx. Okay. So dy over dx equals to negative 4x over fy. I mean negative fx over fy. So our dy over dx equals to negative. And then fx we replace by 4. Okay, so we get this. Okay, fy we replace by 1 plus 4e squared. So we get this. Okay. Alright, then we can use calculator. So we get the final answer dy over dx equals to negative 0.1309. Correct to 4 decimal places. Alright. Coming up next, more examples of partial derivative for implicit functions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.